Hello all, welcome to the statistics session. So once Mark Twain said, facts are stubborn, but statistics are more fallible. Yeah, it's true. So statistics is an essential part of any machine learning algorithm, deep learning model, or any of the part of exploratory data analysis or data visualization. So understanding statistics is always a key role before getting into any data science problem or data related real world use cases and problems. So for the first part of the session, we will be covering the very basic introduction of statistics and the terminologies that we should be familiar before getting into machine learning and in-depth of statistics, theories and concepts. So statistics is a science of collection and analyzing the numerical data in large quantities. To understand statistics, we can say statistics is split into two parts. That is descriptive statistics and inferential statistics. Descriptive statistics says that it is used to characterize and draw insights on the overall behavior of data, and it is used in all stages of exploratory data analysis. So exploratory data analysis in short can be called as EDA. So descriptive statistics is used in all stages of EDA. Inferential statistics is used to infer information about the given population based on the insights from the sample. So to understand better, we can say inferential statistics is used always on the sample, and descriptive statistics is always used on the population of the data. So when I say population and the sample, let us understand this quickly. Let me say I have these data points. In n numbers, I'm going to create this data point. So this is going to be my entire population of my data. So this is my data and this is the entire sample, so entire population of my data. Now whatever analysis I'm going to perform on this entire data is going to be the descriptive statistics. So this is what I called as draw insights about the overall behavior of the data. So when I say overall behavior of the data, it is all about the entire population. But when we speak about the inferential statistics always deals with the sample data. So when I say sample data, let's say I will randomly pick a group of sample from the entire population, and I will do analysis on this population, and I will infer information about the entire population from this selected sample. So this is what we call as an inferential statistics. While choosing the sample from the entire population, we must always ensure that their sample size is large enough to infer information about the entire population. We will see in depth of how to pick the right sample size and how to do analysis on the sample and infer information about the population in depth in the later session of the part of the videos. So quickly moving on to the slides. So the descriptive statistics can be split into three major categories, which will be said as measure of central tendency, measure of dispersion, and measure of symmetry. So measure of central tendency can be further subdivided into mean, median, and mode. Mean is simply the average of the entire data points or the entire data set. So consider we are having a numerical feature and there are some missing values. How will we replace those missing values? We can use a mean to replace this missing value. As I said, mean is the average of the entire data, and median is a part where we utilize the middle value of the entire data. Consider we are having 11 values. We will be taking the sixth value as a median. This is what it is called as a median. Median is all about the center value of the data, but mean on the other hand is the average value of the entire data. Finally, coming to the last part of a central tendency, which is mode. Mode is a frequently acquired data, and mode can be only used on the categorical data and not the numerical data. So what is categorical data and what is numerical data? We'll see that in the next slide. Before that, the next part is a measure of dispersion. Measure of dispersion consists of a range, IQR, variance, and standard deviation. For a simple and quick definition, range, it is the distance between the minimum value and the maximum value of the data set. So we can say the range is equal to the maximum value minus minimum value. So it is the difference between the maximum and minimum values. And also range, it will also give sense of a overall spread of the data, but it doesn't give the sense of a dispersion about the central values, as the range is affected by the outliers. We will see what is outliers, and we will see how the dispersion is affected by outliers in the later part of the session, but this is a general idea of the range. Range is a maximum value and the minimum value difference. And coming to the next part, we have IQR. IQR stands for interquartile range. IQR is also calculated, or it can also be called as mid-spread, hut-spread, and so many names. So that is the measure of statistical dispersion. It is the difference between the 75 percentile of the data and the 25 percentile of the data in a complete data set. So we'll see what is IQR in very depth in the future sessions. So as of now, IQR stands for interquartile range, and it is a difference between the 75 percentile and the 25 percentile of the data set. Theoretically, the data points below the lower fence and the upper fence are considered as outliers. We will see this part also in the part of IQR in the later sessions. Coming to the next part, variance. Variance is the measure of a degree of spread of data points from the mean. As I said, mean is the average of the entire data set. Variance is the measure of the degree of spread of data points from the average value. It is denoted by sigma square. Smaller the variance, closer the individual data points from the mean value. So variance is expressed by squared units always. We have standard deviation, which is called as ST in short. It is the measure of average deviation of an observation or data point from mean standard deviation, converts variance into some meaningful values. So as I said, it is the measure of average deviation or observation from data points. It is not a squared value like our variance. It doesn't have the squared units. Standard deviation is always expressed in the same units as the provided data. And how to vary or how to differentiate between the variance and standard deviation, we will look it into in depth in the detailed part of the video coming in your next classes. So for the next part, we have to understand some terminologies of our statistics, which is variable. So a variable in statistics, whatever we examine is always a variable in statistics. So to understand in depth about variable can be differentiated or split into two types, which is quantitative variable and qualitative variable. Quantitative variable, in which the data is measured in numbers and used for arithmetic calculations. For example, height of the person is considered as a quantitative variable. The weight of the person is also considered as a quantitative variable. The scores that are got in the exams is also considered as a quantitative variables. When I say scores, it's a 60 out of 100, 80 out of 100, or whatever it is, but not the grades as A, B, or C. It's just the numbers. And the temperature of a person can also be considered as a quantitative variable. And speaking about the qualitative variable, anything or any colors can be considered as a qualitative variable, because the data that place things into groups or category is called as a qualitative variable. Segmenting the gender of a person is also a qualitative variable. Segmenting the grades of a student is also a qualitative variable, where we can segment a group based on their grades, and this is all about quantitative and qualitative variable. Further, there is splits on the quantitative variable, where we are segmenting it as discrete variable and continuous variable. For the discrete variables, the variables can be measured in certain numbers, and for the continuous variables, that can take any numerical value based on the accuracy and the scale and the proximity. So for the discrete variable, let me say, if I ask you a question, how many dogs do you own in your house, or how many cats do you own in your house? Your answer will be a perfect number like 2, 3, or 4, or 5. You will not be saying I have 2.5 dogs, I have 3.8 cats, right? So that is what the descriptive variable means. It is a perfect number. So number of dogs, number of cats,